by Gustavo Suarez Quintero, A011994843, Campus Santa Catarina. Andrea Romo Garcia, A0119714 Campus Eugenio Garzazada. Fernando Zambrano Cavazos, A0194885, Campus Santa Catarina. Carolina Avila Cardona, A0119725, Campus Eugenio Garzazada. In this project, we as a team are going to be analyzing what is exponential growth, exponential decay, the implications of using nuclear energy, its main characteristics, its functions, the graph that represents it, the environmental consequence of nuclear energy, and the Chernobyl nuclear reactor disaster, and how it happened and how it could have been prevented. With these topics, we are going to be implementing and learning about the nuclear disaster mentioned before, Chernobyl. Chernobyl was a catastrophic nuclear accident that occurred on April 26 of 1986. As you know, nuclear energy can be used to produce electricity. This energy can be obtained in two ways, nuclear fusion and nuclear fission. In nuclear fusion, energy is released when atoms are combined or fused together to form a larger atom. The sun produces energy like this. In nuclear fission, atoms are split into smaller atoms, releasing energy. This is an example of an exponential growth. This is focused basically on the pattern of the atom's growth when this nuclear disaster happened. Actually, nuclear power plants can only use nuclear fission to produce electricity nowadays.
Exponential function is a function whose value is a constant raised to the power of the argument, especially the function where the constant is e. Right now, I will introduce you to the idea of an exponential function. So here's a basic example of an exponential function. It says function of x equals 3 to the x. Why is it called an exponential function? Well, because the input of our function is in the exponent. Now, here we have a table that gets the y values. Now that we've got the values, we're able to graph it. So check out how the values grow or explode quite quickly. Right here we're getting numbers closer and closer to 0, but never touching 0. The domain is all real numbers and the range is all real numbers greater than 0. So we can see here how this function explodes quite fast. Now I'm going to talk about exponential growth, which is defined as growth whose rate becomes ever more rapid in proportion to the growing total number or size. For example, nuclear fission, the splitting of atoms. This starts with one atom of uranium. One accelerated neutron is fired at the atom to begin the reaction. When the neutron strikes the atom, it splits, creating two different elements and releasing energy and three neutrons. So for every atom split, 3 more neutrons are released along with energy, resulting in exponential growth and mass destruction. This is what happened at Hiroshima and Nagasaki. Here we have a big explosion. This can also be demonstrated by the equation function of x equals 3 to the x. Y is the amount of neutrons released during fission and x is the amount of chain reactions. So, because fission cannot be negative, the asymptote equals 0. The domain includes all real numbers and the range is over 0, and we can see how this explodes fast, like an explosion.
On April 26, 1986, a major accident occurred at Unit 4 of the nuclear power station at Chernobyl, Ukraine. The operating crew was planning to test whether the turbines could produce sufficient energy to keep the coolant pumps running in the event of a loss of power until the emergency diesel generator was activated. To prevent any interruptions to the power of the reactor, the safety systems were deliberately switched off. To conduct the test, the reactor had to be powered down to 25% of its capacity. This procedure did not go according to plan, and the reactor power level fell to less than 1%. The power, therefore, had to be slowly increased. But 30 seconds after the start of the test, there was an unexpected power surge. The reactor's emergency shut down, causing the reactor to explode and liberating an enormous quantity of radioactive waste into the atmosphere. The Chernobyl nuclear disaster could have had a lot less probability of occurring, all because the operators ran the plant at very low power, without adequate safety precautions, and without properly coordinating or communicating the procedure with safety personnel. The reactors also were highly unstable at low power, primarily owing to controlled rod design and positive void coefficient, factors that accelerated the nuclear chain reaction and power output if the reactors lost cooling water. These factors all contributed to an uncontrollable power surge that led to Chernobyl Fort's destruction. The power surge caused a sudden increase in heat, which ruptured some of the pressure tubes containing fuel. Vast territories were contaminated, and trace deposition of released radionuclides was measurable in all countries of the Northern Hemisphere. There were health impacts. Numerous studies have done on possible effects of nuclear power in causing cancer. There is an agreement that excess cancer in both plants, workers, and surroundings public have been caused by accidental releases such as Chernobyl accident.
So in conclusion, we learned a lot about the nuclear energy. For example, that it has one of the lowest impact rates of any energy source we use on the modern era, and that there is only one nuclear power plant in Mexico. It is located in Laguna Verde, Veracruz. It is a very safe power plant since it takes the safety regulations very seriously. However, the people that live there are very concerned that an accident like Chernobyl might happen. Now, the operators in Chernobyl ran the plant at very low power without adequate safety precautions and without properly coordinating or communicating the procedure with safety personnel. It could have been avoided very easily. It had made major effects in the environment, killing lots of animals and people. In this activity, we also learned about exponential growth and exponential decay. Exponential growth, it is the value of a mathematical function that is proportional to the function's current value, making it grow. While exponential decay is when it decreases in quantity according to the law. Working in a project like this was very interesting since we don't know each other, but we found a way to work as a team and make the project less difficult and made it work.